So do Starlink satellites have to be reprogrammed to communicate using T-Mobile's radio band? Actually, we need to do more than simply reprogram the satellites. We are constructing special antenna. Like I said, they're actually very big antenna that are also extremely advanced. They're the most advanced phased array antennas in the world, we think.
This audio recording was made possible by organizations working together for people, not profit.
And pause for a moment and consider this, if you will. This is really where all sensor technology began. All the programs of the present day, the PRISM programs, etc., the NSA, that people worry about and wonder about and are curious about, they all began right here in Vietnam. And they began with this idea of McNamara's electronic fence.
And it has to be, the antennas have to be extremely advanced because they've got to pick up a very quiet signal from your cell phone. And you can imagine if that's like cell phone, that signal's got to travel 500 miles and then be caught by a satellite that's traveling 17,000 miles an hour. And the satellite's got to compensate for the Doppler effect of moving so fast.
That large, weird, dart-looking thing with the antennas coming out of it, that's what's called an ADSIG, and it's actually an audio detection device. And the guys who I interviewed for this book, the VO-67 Navy crew, would get into that aircraft and they would fly low and slow over some of the most dangerous parts of the Ho Chi Minh Trail. And they would drop those sensors out in a string. And they would come hurtling out of the aircraft and they would sort of land in the ground. Hopefully a lot of them fell on the side. And the idea was to create this string of sensors with audio technology. The information would be sent up to an aircraft that's flying around in a racetrack formation. Then it goes back to an information center at an airbase, a U.S. airbase in Thailand. And then everyone's using these new things called computers.
So this is really quite a difficult technical challenge. But we have it working in the lab, and we're confident this will work in the field. So it's actually quite a lot of extra hardware on the satellites, and it's also a lot of software. Yeah, it's a hard problem. That's why it's not been solved before.
There you see another. That's a different version of things being thrown out of a helicopter. There were also seismic sensors that were going out, magnetic sensors. This was early sensor technology. You can see how big it is. I mean, now these sensors are so small. DARPA even has some new technology I've been told about, but is not. I could not verify because it might still be in the classified department. Sensors that you actually cannot be seen, but they go on people's fingertips unwittingly. So when they're typing, everything is going back. And when you think about that concept, this all began on the Ho Chi Minh Trail. It's pretty remarkable.
So the question is the invitation for all carriers across the world or just the U.S. to start? One of the beautiful things about satellites is that they orbit the Earth. And so, our mutual view was the more companies around the world we can get signed up for this, the way T-Mobile is signing up for it tonight, the better. Because, and what we're offering is reciprocal roaming, so that our spectrum, which will be transmitted by the satellites all around the United States, including territorial waters, vast portions of Alaska, Hawaii, Puerto Rico, big swaths of the ocean potentially, will be available to visitors in the United States that have carriers all over the world.
No amount of technology could go up against this, which was student protesters.
And our view is that the best way to do this would be to ask them to also participate. Find a piece of mid-band spectrum in their country from their carrier that they can dedicate to this in partnership with SpaceX, and then our customers would benefit from the same thing when our customers visit their country. And that's one way this could roll out. And so tonight's message is a call to those carriers to get involved and join the party.
So this is an open invitation to carriers around the world. Please get in touch with us, and we'd love to partner with you and enable this globally. But
it was interesting because this fellow came in, Harold Brown. and he came up with a new strategy which was making science and technology industry at the Pentagon. And he put into play long-term research projects with all of that sensor technology I was just talking about, and that it would build. And then now with Harold Brown and the Pentagon, this movement came toward creating a system where it wasn't a fence, it's an area network, and we can watch and survey that. So they being the Pentagon, DARPA, began looking at some of the technology from the Vietnam War and rebundling it and working with the fact that all technology was becoming nanotechnology. Not quite yet, but in other words, things were getting smaller. And as things got smaller, they could be more effective in the war theater. And these are two of the earliest drones from the Vietnam War. This is like a reconfigured helicopter that used to fly off of a submarine, and then the guy in the Jeep is driving around with all that technology, gathering the information, video and audio. And they really had very little effect on winning the Vietnam War, but it's certainly a different story now. So the Pentagon spent all the way until the late 80s pushing technology, pushing sensor technology, pushing drone technology, building entire industry. The ARPANET became the internet. And there was a movement toward what is now called network-centric warfare. And in the Gulf War, with Secretary of Defense Cheney in charge, the idea that technology could win a war like that became evident instantly, and you can see that. This was called the Highway of Death, and this is just the results of that kind of technology. That stealth fighter back there, the F-117, which was another DARPA project, again, stealth, early workings in Vietnam, 20 years secretly in the making, 10,000 Lockheed employees, by the way, were cleared for the Skunk Works program. Not one single leak ever in that 18, 19 years until it made its debut in the Gulf War. But that took a lot of the limelight when in fact there was so much other DARPA technology going on in that Gulf War. I write about it in the book. And most importantly, something called J-STAR. So that old idea from Vietnam of having an aircraft flying around in circles trying to gather the technology from those giant sensors had gotten shrunk down. So you had this computer in the sky. It had 600,000 lines of code, gathering up the technology during the Gulf War and relaying information, early drone technology. The Pentagon had a big problem in urban warfare, and they knew it, but this was what their idea of what urban warfare would look like, which is really laughable. They had like a little drawing here of what looks to me like a German village. So DARPA again got pulled away when this happened, Mogadishu, Somalia, 1992, and there was lots of activity at DARPA talking about how America was going to deal with the possibility of having to fight wars in urban environments. They would quote Sun Tzu a lot from 2,500 years ago. Sun Tzu said the worst idea is to attack cities. And there was a lot of debate at DARPA, like the worst idea is to attack cities, but what are we going to do about it? Another interesting thing happened at DARPA right around this same time, which is the Berlin Wall fell. And when the Berlin Wall fell, a number of very serious Soviet scientists who had been working on biological weapons programs defected to the United States, and they began working for DARPA. And this is Ken Alibek, whom I interviewed. He's back in Uzbekistan now, but he was a major player in the biological weapons program and was very controversial because some say that he created the problem that then needed to be solved. So again, you see that conundrum, which is a bit like the nuclear weapon issue, the thermonuclear weapon issue, that you create a weapon that then you must defend against. But Alibek worked for us for a long time before he left the country. And what was interesting about these Soviet scientists is, in terms of the big picture of DARPA, was that before then, there were no biologists at the Pentagon. And that's kind of a term that scientists will throw around loosely, but it's pretty accurate. DARPA was interested in what I call the supermen of science, the Murph Goldbergers, the Jason scientists, the physicists. The engineers. Biology was considered soft science. That all changed. And that has taken us in a very different direction because we're now looking inside the body. And again, things took a very big change after 9/11 because suddenly we had to deal with urban warfare and we had to deal with this biological weapons threat. But you cannot prepare for everything. And what happened to DARPA in the early days of the Gulf War was that a $25 homemade bomb called an IED was very quickly became responsible for 63% of coalition deaths. And suddenly we spent $6 billion trying to create technology called Defeat the IED technology, and this involved computers. We created jammers to try to jam the IEDs, and then the terrorists would create anti-jamming devices, and this went on, and many, many people died. I write about the different technologies that were looked at during the War on Terror by DARPA in this process. So then finally one of the solutions was the robots, and that is a Talon robot, and it's an example of, at least to the EOD techs that I spoke with, of how robots are saving lives in warfare. These robots can go in and do a lot with looking at the IEDs and sending back information to operators and even remotely dismantling some of them. But another idea that sprang forth was this idea from the electronic fence. DARPA pumped an enormous amount of money into its urban operation programs, and it created a system called Combat Zones that See. And that little WASP drone there being shot off the arm of an operator it weighs just a few pounds, and it has some of the most incredible technology. All the specs are in the book. It flies in a swarm. If one of them is lost, the others will reconfigure. And what they're doing is taking audio of an area. So, for example, if a unit goes into the war theater and they understand that there's a terrorist hideout over there, they'll send the WASPs in, and they will be taking video and audio in real time and painting the picture for the operators on the ground. The robots have moved so quickly into a kind of advanced technology world where it's really impossible to even consider how fast things are moving. This is called the Modular Advanced Armed Robotic System. It can kill a human target 2 miles away. It has everything that was ever designed in Vietnam shrunken down to the size of my fingernail and more. It also has encryption software so that no one can get a hold of it. But this is where our defense systems are going. And there we have the Atlas robot, same thing, looking more and more like people for a very important reason. These are actually the L3 robots. They carry the load. But what's also fascinating about the L3 is that it works on an operator's voice command. So the commanding officer talks to the robot through a headpiece and it follows. And if you've ever seen these in video, it's astonishing what they can do. I mean, they can fall over and get back up. They can climb terrain. But again, these are just the DARPA robots that we know about. I went to Los Alamos to look at the synthetic brain that DARPA is creating out there. This was the only picture I could get. It just shows the force protection outside. Inside, DARPA's using what's left of this IBM Roadrunner supercomputer, which in 2008 was the fastest computer in the world. It has since become obsolete. It was $100 million to build, but of course Los Alamos needs the best computer that there is. So, and they can't, reuse it because it has the nuclear codes on it. So they're incinerating it. But in the meantime, little pieces of it are being used to help power this synthetic brain, which really begged the question for me. Was like, is that a good idea? But what I really think, and what I write about in the end of the book, and I'm going to leave you with this thought, which is that the idea of dual use. All technology has dual use, and you often hear, the Iranians are always getting in trouble for dual use technologies. But, DARPA does this too, and here's an example. This is this incredible prosthetic that DARPA makes. But from the guys I spoke to who actually use this limb, it's really not as incredible as is often cracked up to be. There are problems with it, and so most of the guys who use this, or who appear on 60 Minutes or whatnot showing how great the prosthetic is, they go home and they put back on their Dorrance hook, which is that hook from 1922 technology. So this looks good, but is it really working? And what I believe is going on at DARPA is that this dual-use technology, the synthetic brain, the robots, we're moving. I found a document at the Defense Department that talks about human-robot interaction, and that is the movement that the Pentagon is taking us toward, which is where robots and humans learn to sort of love each other. And the idea that we are creating cyborg drones, which we are. We now have rats that we can control, and we have moths that we can steer at DARPA. Getting humans, and to be ultimately turning over the reins to autonomous weapons. And one of the ways in which that I find difficulty in wrapping my head around this, and DARPA was one of the few places they absolutely would not let me go, which was interviewing soldiers who now have come back from that war in Iraq, the wars in Iraq and Afghanistan, with traumatic brain injuries. There are 300,000 of these soldiers. And the programs that DARPA has put brain chips in the brain and are working with sending electronic signals. And in some cases, if the soldiers have PTSD, it's a kind of electroshock therapy on the go. In other cases, they're trying to repair cognitive functioning. But it really does beg the question, what is the dual use? And from the scientists that I have interviewed, it appears that DARPA now believes that brain-computer interface, the technology there, will push us toward that artificial intelligence which has long been sought and coveted and has not yet been attainable. And the Jason scientists who I spoke to, these are old men who passed on some words of wisdom, said that and showed me this report. They had written a report saying DARPA should not be doing this. This is a dangerous area to get into because it is leading us toward brain control. And so DARPA has, just in the past few years, pushed the Jason scientists aside and now takes their advice from an in-house Pentagon organization called the Defense Science Board.
This audio recording was made possible by organizations working together for people, not profit.